Hi, I'm Ahmed Daud, and in this session we will see how we can do post pruning by using sklearn. Okay, so it is quite simple. If you will see that documentation, decision tree classify from sklearn.tree. So here there is a one hyperparameter which is CCP alpha. It is cost complexity parameter which is alpha. Whatever you will pass the value to that hyperparameter, you will get a tree according to the mentioned alpha value. Okay, like we were having in the when we were studying theoretically, as I mentioned here, whatever you will pass the value of alpha, you will start from fully grown tree. You first build fully grown tree, then prune the tree with respect to minimum alpha and stop when the prune tree has minimum alpha greater than the your past value, your mentioned value. So the same process that sklearn will follow when I will pass some value to that parameter. Okay, this is one of the parameter that is related to the post pruning path, and the second which is this cost complexity pruning path method. Okay, this method is also related to the post pruning approach. What actually it do, it compute the pruning path during the minimal cost complexity pruning. What is meant by pruning path, I will tell you in a while. We can pass here the training data set, and it will return some dictionary like object, which by using that object we can access both attributes, ccp alphas and impurities. What is meant by that, it actually return the fully path like we are having here. As we are having a fully grown tree, then we were doing pruning with respect to minimal alpha, and we are getting different values of alpha at each stage, and we are getting according to that alpha value different trees. Okay, and as our trees are updating, our impurities are also keep on updating. Okay, or you can say keep on increasing. So the whole path, this whole path, it can return this cost complexity pruning path method. Okay, we just pass the training data set, and it can return all the alpha values, all the possible alpha values, and all the impurities corresponding to each alpha value, or you can say corresponding to tree with respect to each alpha value. Like this is the impurity of the tree which has alpha value 0. This is the impurity of the tree which has alpha value 0.005. Okay, in that way, this cost complexity pruning path, this method can return the uh, all the possible number of alpha values and their corresponding impurities. Okay, if you will go to that particular documentation, this is the brief explanation like I told you in the last session, how the process is carried out, and there is one example is listed here. If you will go to that particular site, you will get an example in which they have explained quite well how the post pruning part is carried out by using sklearn. And there is one very sophisticated example and a lot with some graphs also. Okay, so come back towards the today's session. It will be a very simple session in which we will do the same like here. This iris data set we will use, and the same decision trees we will get, and this type of data frame we will get. Okay, here as always I am importing my NB Black extension, then some of the imported libraries, and then the iris dataset I am loading here. And for the sake of simplicity, I am just getting or keeping my petal length and petal width in my final dataset. Then I have here data frame 2, which has two independent variables. Both are numerical form, and one is target variable which is of categorical form or object type. And we don't need to do converting that categorical variable into numerical, because sklearn can detect by itself. Okay, so I am have split it into x and y, and then I have split it into train and test data set. Here first I am going to build the decision tree. Here the instance of decision tree, and then with the default hyperparameters, means there will be no restriction on the growth of the decision tree, or you can say the algorithm that is responsible for the growth of tree. There is no restriction here. I am here training my uh, classifier decision tree with the default hyperparameters, And here you can see it is giving already quite good score, 99% score on the trained data set and 100% score on the test data set. Okay, so for this particular case we don't need to do some pre-pruning and post-pruning, because the default model is not leading towards the overfitting. It is all already giving us some good score. But for the sake of explanation or getting idea, we will carry out the process of post-pruning. So here are like three classes in that data set, and there are two input variables. So this type of you can say decision tree, my default hyperparameters, sklearn with default hyperparameters has built the decision tree like this. Okay, and we have seen that in the theoretical part also. There are a lot of nodes. There are 8 leaves, there are 5 depth. Now we will do the post pruning part. First we do in like we did in the previous case, we first create an instance of a decision tree classifier from the sklearn, and then instead of first training that algorithm, I am going to use my cost complexity pruning path method from the sklearn, and here I am passing my training data set. What it will do, it will train the fully grown tree, and then then prune the decision tree with respect to minimal alpha, and keep on pruning until it will get just one node, which will be just the root node. Okay, and along the way when it is doing pruning, it will save all the alpha values and their impurities corresponding to their trees. Okay, and it will return the all the alpha values in the form of array and all the impurities in the form of array. Then by using that alpha values, because it can return all the possible alpha values in that case of that particular decision tree, then by using that alpha values we can build multiple decision trees. Okay, so I am passing here training data set, and to that particular cost complexity path method, which is I am accessing by using my that instance that I have created from the decision tree classifier. So it is returning my to me some dictionary like object, which is I am saving in the path variable, and by using that object I am accessing their attributes CCP alpha and impurities, and I am passing these into the two variables alphas and impurities. Here you can see it has returned all the possible number of alpha values, or you can see the whole path and their corresponding impurities. Okay, these are the impurities of the corresponding trees. Like this is the impurity of the whole tree which has alpha value 0. This is the impurity of the whole tree which has alpha value 0.005. Okay, in that way, if we will want to see that CCP alpha and impurity in the form of data frame, you can see, and it is the same that we have discussed theoretically, that here we have some alpha values in some increasing order, like we this cost complexity pruning path method has pruned in the same way. It will start from fully grown tree and keep on pruning with respect to minimal alpha. Okay, and it will save all the alpha values in the form of array. And here we have 8 possible alpha values. The first alpha value, which is 0, it is if we will pass that value, and whatever we get a tree, it will be the fully grown tree. Okay, very complex tree, or complex tree out of all. And the last tree, if we will pass that alpha value in the decision tree, then we will get the very simple tree, which is just a root node. Okay, and now we will plot a graph, and we will explore that how with the increase of alpha values our impurities are increasing. And you can see as our alphas are increasing, our impurities are increasing, and it is quite straightforward, like we have discussed here also. Like as our alpha is increasing, because we are pruning with respect to minimal alpha, and of course in the next case of alpha, or in the next iteration, whatever tree we will get will have the minimum alpha value greater than the previous case. Like this 0.012 is greater than the previous case. Okay, and as we are keep on pruning our decision tree with respect to minimal alpha, our tree becomes simpler and simpler, and as our tree becomes simpler and simpler, our impurities will keep on increasing. Okay, because when we are growing the full tree at the very start, by the default algorithm or default hyperparameters, we are keep on splitting our data set to get to where we have some decrease in impurity for the sake of to minimize the impurity, to make the impurity of the data set approach to zero. Okay, when we will prune our tree, then of course we will increase our impurity of the tree. And here you can also visualize from the graph, as alpha is increasing, our impurity keep on increasing. Okay, here I am going to create a list to save my classifiers, and here I have the array of my alpha values, and now I will create the number of decision tree against each alpha value by using the same technique that I have told you here. Like whatever value you will pass, you will get the tree by using that steps. Okay, start from fully grown tree, prune the tree with respect to minimal alpha, and stop when your pruned tree will have minimum alpha greater than the your specified value. Okay, so here I am passing one by one each value to my decision tree classifier. Here, this one in this hyperparameter, which is you can visualize here. This one hyperparameter, which is the last one, corresponding to the post pruning or post complexity pruning method. So I am passing one by one each value to that particular hyperparameter, and here I am creating the instance with respect to that particular hyperparameter. Then I am going to train my classifier on the my training data set, and it will train first full grow the full tree, then the prune the tree with respect to minimal alpha, and stop where the prune tree will have minimum alpha greater than that value, that particular value. Okay, then in that way I can get a classifier corresponding to that given alpha, and then I am going to append my classifier into my classifiers list. In that way I can I by running a loop I will get all number of classifiers or all number of decision trees corresponding to each alpha value. Okay, so there are this is just for the sake of to see the last decision tree, or you can say the uh, decision tree corresponding to last value alpha. A number of nodes in the last tree is 1 with respect with alpha value 0.312, and you can see that 0.312 is the last value alpha, and it is definite that this will have just one node which will be a root node. You can also see from now I have a list of classifiers. Okay, and like here I don't need to do um, post pruning, but it is just for the case of sake of explanation. But if I will need here, what I will do, I have some number of classifiers. Okay, I will test each classifier on the testing data set, and which will give me good score. I will select that classifier as my best classifier or best decision tree. As here there is no need, so I will not go towards to test that classifier, but in the next session we will do. Okay, so here I have a list of classifiers. Now I want to visualize each classifier present in that list. So here, this is the list of classifier. The first is a classifier with the alpha value 0, and the last classifier with the alpha value 0.312. And there are total number of 1, 2, 3, 4, 5, 6, 7. There are total 8 decision trees or classifiers we have with different alpha values, and alpha values are in some increasing order. So first of all, I am going to explore my classifier that is present at the or decision tree that is present in at the zeroth index, which will have alpha value 0, and it will be the fully ground tree. Then I am going to explore my classifier which is at the index 1, and it will have the alpha value 0.005. Okay, uh, so this classifier will have less number of branches compared to the fully grown tree, and we can analyze here. Like in the case of node number 14, in the fully grown tree there were these two branches, but it is pruned because they have minimal alpha value compared to all non-dominant nodes, so that's why it is pruned here. And this node number 14 was having the alpha value 0.005, so that's why we have pruned, and we get another tree which is at the index 1. Okay, then again we will see analyze another tree with the some greater alpha value, and it will have less number of branches compared to previous one, and in that way we will keep on increasing our alpha values. from because we have some range or some finite number of alpha values in some increasing order. We'll pass one by one each alpha value, and we will get some different tree. And each time when we are passing some higher alpha value, we will get some simpler model, some simpler decision tree, and you can see here. Now at the index 4, I have classifier which has very less number of branches, and at the index 5, more less than more simple decision tree I am getting. At the 6, very simple decision tree, one root node, and there are just two branches. And at the end, the classifier that is present at the 7th index, it is just a root node. Okay, so in that way you can get a multiple classifiers corresponding to alpha values. And like here we don't need, but in the next session we will do, we will test each classifier on the testing data set, and which classifier will give us some good result, we will select that classifier as our good classifier or as our good decision tree. Okay, so this session was just to introduce you to the cost complexity pruning path method from sklearn and the cost complexity parameter alpha from the sklearn. So for now, thank you.